Hello friends, we are discussing solid state and we have cubic crystal system to discuss. So the cubic crystal system, in cubic crystal system we have three Brevis lattices. One is called simple cube, alright, or primitive, and then we have FCC kind, that is FCC, and third is BCC, body centered cube. Something you must remember, it is not possible to derive all these things. For simple cube the radius is equal to a by 2. Here r is equal to a by 2 root 2, and for BCC r is equals a by root 3 by 4a, root 3 by 4a. All right, and then there is nearest neighbor distance, or Rc positive plus Ra negative. If it is an ionic crystal, Rc positive plus Ra negative, this is multiplied by 2, so it becomes A. Rc positive, here Rc positive plus Ra negative, that is the distance between the distance of the center between these two is a by root 2. All right, and here the nearest neighbor distance, that is Rc positive plus Ra negative, is equals, this is root 3 by 2a. all right, means this relation just multiplied by 2, you get this relation. All right, then comes packing fraction. Here the packing fraction is 0.524 or 52.4%. Here the packing fraction is 0.74 or 74%, and here it is 0.68 or 68%. all right, so these values, these data you must remember. all right, and then comes the total number of constituents per unit cell. The total number of constituents per unit cell is given by number of constituents present at corner divided by 8, because the contribution of one atom or one sphere at corner is 1 by 8. So Nc by 8, and then Ne by 4, then plus you can say n f by 2, that is number of atoms on faces, Ne number of atoms or constituents on edges, and plus Ni number of constituents inside the cell. So if you want to calculate number of constituents in simple cube we have constituents or atoms only at the corners. So for simple cube we can say it is 8 into 1 by 8, that is equal to 1. Whereas for face centered cube we have NC, means 8 into 1 by 8 is equal to 1, plus we have in FCC we have constituents at faces as well. So it is 2 into, means total number of faces in a cube is equal to 6, and contribution is 1 by 2, that is equal to 3. So total number of constituents per unit cell is equal to 4 in FCC. And in BCC we have 8 atoms at corners, so 8 into 1 by 8 equal to 1, and we have 1 in the center, so we have total of 2 constituents. So in FCC total number of constituents is 4, in BCC total number of constituents is equal to 2, and in simple cube total number of constituents is equal to 1. So from there you will find many questions, many numericals from this section. Say suppose we are given one or two examples. Let us see. We have AB. all right, here AB, it forms a cubic crystal system. It is mentioned AB forms cubic crystal system where A occupy all the corners. all right, A occupy all the corners, and B is present on all the faces. What is the formula? So see, if it is at corners, so it is 8 into 1 by 8 equal to 1, and B is at faces. So how many faces are there in a cubic crystal? There are 6 faces. Contribution is 1 by 2, that is equal to 3. That means the formula becomes AB3. This is not valency, means you don't have to cross multiply it like this. This is wrong. This is A is equal to 1 and B is equal to 3. Alright. Now look at one more case. AB forms a cubic crystal. A occupy all the corners. It is mentioned that A occupy all the corners and A is present. A is also present in all the faces. Alright. And B is present in all the edges, suppose. B is present in all the edges. Alright. What is the formula? So since A is in corner, so it is 8 into 1 by 8 equal to 1. A is also present on faces, so 6 into 1 by 2, that is equal to 3. So total A becomes 4, and B is present on all the edges, and total number of edges is 12, and the contribution is 1 by 4, that is equal to 3. So the formula becomes A4B3. Alright. Or we have say ABC type of cubic crystal system. A occupy all the corners, alright, and B occupy all the faces, and C occupy all the edges. Alright, this A occupy all the corners plus in the center, suppose in the center. Alright, what is the formula? So here A is present in all the corners, so 8 into 1 by 8 is equal to 1, and in the center 1, so 1 plus 1, 2. Alright, and B on all the faces, so 6 into 1 by 2, that is equal to 3, and C at edges, so it is 12 into 1 by 4, that is equal to 3. Alright, so how many A? A2, B3, C3. This is the formula. Alright, so by this way you can solve the cases. So we have, and then comes the voids or interstitial spaces. Alright, interstitial spaces. Two interstitial spaces are very important. One is octahedral void, and one is tetrahedral void. You must know the location of octahedral void. Octahedral void is present. One is present in the center. One is present in the center. We have all the crystal system, that is CCP kind. CCP is also called FCC. CCP and FCC are same. Alright. In CCP or FCC, we have octahedral void. Voids are the spaces unoccupied by the spheres or atoms or constituents. So one octavoid is in the center, and octavoids are also present on edges. These are the two positions where octahedral voids are present. So in the center we have 1, and edges it is 12 into 1 by 4, that is equal to 3. Alright. So 1 is in the center and 1 means on all the edges, alright, of a cube. And tetrahedral voids are present on all the corners. All corners means you should be careful. At the corner we have the constituent. It is just inside the cell. We have tetrahedral voids. Now suppose we have a crystal system. Alright, we have a crystal system, that is AB kind of crystal system, and it says that A forms CCP. If it is mentioned that A is forming CCP, that means A is present in all the corners. Alright, plus it is present in all the faces. So total number of constituents is equal to 1 and 3. Total number is 4. And if there are n number of spheres, then number of octavoid is equal to n, and number of tetrahedral void is equal to 2n. Means if we have n number of spheres, if we have 4 number of spheres, like in this case we have 4 number of spheres, these 4 spheres will create 2 types of voids. One is octahedral void, it is creating octavoid. So where are octavoids are located? Octavoids are located one in the center, that is equal to 1, and second on all edges, and all edges it is 12 into 1 by 4 equal to 3. So how many octavoids are created? 4. And it is created by whom? The one sphere or constituent which is forming CCP. The constituent which forms CCP creates 2 types of void, octavoid and tetravoid. So since there are 4 number of spheres creating octavoid, how many octavoids are created? 4. See, if there are n number of spheres, we are getting n number of octavoids. Alright. And how many tetravoids? Where are the tetravoids? Tetravoids are located at all the corners. And how many corners are there? There are 8 corners. So how many tetravoids are created? 8. If there are n number of spheres, how many tetrahedral voids are created? It is 2n, that is equal to 8. Alright. So if we are given a question, that is AB, in AB type of CCP, A forms CCP and B is present in all octavoids, what is the formula? So A is equal to 4, A4, and how many octavoids are there? 4. So, and B, where B is present in octavoid, so B is 4. So we can say what is the formula? It is AB. Alright. Look at one more case. Say suppose we have AB crystal system where A forms CCP and B is present in half of the tetravoid. B is present in half of the tetrahedral void. What is the formula? So tetravoid, how many tetravoids are created? 8. Means CCP, A creates CCP. So how many A? 4. So number of tetravoid should be double of this value. Alright. So if there are 4 number of spheres, number of tetravoid created is 8, and half of which is occupied by the tetrahedral void. The half of this is occupied by tetrahedral void. So it is 8 into 1 by 2, that is equal to 4. So what is the formula? Becomes again AB. Alright. Now look at one more case. Suppose we have AB crystal system where A forms CCP. Alright. A forms CCP and B is present in all the tetrahedral void. B is present in all the tetrahedral voids. What is the formula? So A is equal to 4 and B is equal to 8, means A4 B8, and the simple formula becomes AB2. This is the formula, simple formula, AB2. Alright. So by this way you can solve numericals. Alright. Then there is one more relation, that is density. Density is equal to Na upon Na cube in gram per centimeter cube. Here n is the number of spheres, number of constituents per unit cell. Here n is number of constituents per unit cell. A is the mass number, capital N is the Avogadro number, and A is edge length. Alright. So this is density in gram per centimeter cube. If A is mentioned in picometer, it must be converted to centimeter. So 1 pm is equal to 10 raised to power 1 pm is equal to 10 raised to power minus 10 centimeter. So by this way you can calculate the density of unit cell. All right. So these are some important points in solid state.